Hi all, now we are going to see the phase locked loop motor speed control system. This is the block diagram of the PLL control. So we have the motor, the speed of which is about to be controlled or locked. We have a tacho generator here which is going to sense the speed of the motor and feed it as a feedback signal, and it will be compared with the reference signal. The frequency and the voltage of the motor is detected and it is compared by the phase detector here. The phase detector is like a comparator which is going to check the feedback or the motor actual speed and frequency, and it is being compared and it detects whether there is a phase difference or not. If there is no phase difference, then that particular frequency is locked, and this locked frequency is passed to a low pass filter, after which this output voltage is fed as the motor driver input, which is passed on to the motor. Now, based on this, the motor now, as the phase is locked or the motor speed is locked, the motor will right now run in a continuous constant speed. There won't be any variation irrespective of the change in the load. Even if in case there is a change in load, then that will be fed back to the phase detector through the AC generator to the phase detector, and it is compared with the reference signal, and the phase detection will be, or the difference between the reference and the actual is being detected or compared, and it is passed on. Accordingly, a motor driver circuit will be passing a signal or a voltage. Hence, whatever may be the change in the load, whatever may be the changes that occurs to the motor, that will not affect the motor speed, and the phase difference is expected to be between 180 degrees. So whatever may be the change in the load, that is sensed and it is detected, and it is compared and given back to the motor detector. Accordingly, the signal is passed, and once it is changed, then it is again locked. Once the motor runs in the same voltage and the frequency, then it is compared and then it is locked. So there won't be any change in the motor speed. This is how the phase lock loop works. And the applications of the phase lock loop is wide. You can use in manufacturing systems, you can use in robotics, wherever we need a precise control, accurate control of speed, then you can go on with the PLL control. It has wide applications in automotive systems, like when we deal with the powertrain architecture of the vehicles, then the frequency and the voltage of the motors are also being dealt, and it is locked by the phase lock loop. And in a normal consumer electronics, also in drives, we try to use this phase lock loop to control the speed or to match the frequency and the voltage of the actual system. So there is a wide spread application of phase lock loop system for the motor control, and this is the block diagram description of it. Thank you.